Hey guys, today I want to talk to you about the polynomial remainder theorem and the factors that you can find in divisions with this theorem. So let's do it. So we know that the polynomial remainder theorem states that if you have a polynomial p of x and you divide that polynomial by a linear term, its remainder is going to be equal to the polynomial evaluated at that a value, okay? It's a pretty simple theorem that exists in math. Now, one of the applications of this theorem in math, of course, is to find the factors of, or you could say the perfect factors of a polynomial. So let me show you what I mean by that. So for example, let's suppose I have the following value. If I have x squared minus x minus 12, for example, and I'm going to divide this by x minus 4. Now we can compute the remainder of this division and see something. So we're going to say that its remainder is equal to the function evaluated, or well, the polynomial evaluated at 4. So we have 4 squared minus 4 minus 12. This is going to be equal to 16 minus 4 minus 12. Minus 12, I forgot, yeah. And this is, of course, going to be equal to just simply 0, okay? You get 12 minus 12, 0. Now, what does it mean that a remainder equals 0? When you have something that equals 0, for example, I'm going to give you a simple one. 9 divided 3. What you're basically saying here is that how many times does 3 fit, or you can place its size or its magnitude inside 9. We know 9 is just simply equal to 3 plus 3 plus 3. Okay? You can fit 3 into 9 3 times. That is why the result of that division is equal to 3 plus nothing else. Okay? This is the remainder that is 0. But for example, what if we had 10 divided 3? Now, in this case, this division would be equal to, I mean, you could represent it as 3 and a remainder. So you can, how many times can you fit 3 into 10? 3 plus 1 more unit. So that means that this division is 3 and a remainder, rem, of 1. And this division has a remainder of 1, okay? That is basically what we are representing here. Now, what I'm trying to show you is that you have a perfect division if your remainder equals 0. That means that your denominator can fit into your polynomial a perfect amount of times and have nothing else like additional to that value, okay? So, in the case of this polynomial, that implies that x minus 4, since it can fit into the polynomial a perfect amount of times because we get it in a remainder of 0, it means that x minus 4 is a factor of the polynomial that we have, x minus 12, okay? And now this is indeed true, because if you were to factor this, how do you factor this? Well, we know how to do that. We know it's x, first sign that you have, another one, multiplication between the signs, so you get plus. And now this should be equal to two numbers multiplied that give you 12 and give you 1, negative 1, 3 and minus 4. So minus 4 and 3. Now, this is one of the factors. Remember, a factor is the two things, or well, two or more things that you multiply something to get a specific product. So x minus 4, we can see in this factoring that x minus 4 is indeed a factor of this polynomial. And this makes sense because if you have this, what you can do is you can divide both sides of this equation by x minus 4, and you would get what we had before, x squared minus x minus 12 divided by x minus 4. And this should be equal to this value right here, x plus 3, with a remainder of 0. Okay? I hope this makes sense and this shows you something. Basically, if you get a remainder of 0 when applying the polynomial remainder theorem, and you get a remainder of 0, that means that your denominator is a perfect term, or a perfect factor, I'm sorry, is a perfect factor for the polynomial that you have in there. Okay? Because you can fit it into the polynomial a perfect amount of times, or an integer amount of times, you could say it like that. Now, also this implies that this division, if you see it in terms of its quotient, should be equal to x plus 3. So let's see if that is actually true. So we should get that that division is equal to, so we have a coefficient of 1, -1, and -12. And we also have 4, that's the number we're going to be playing with. So we get 1 times 4, we get 4. That's the most awful 4 ever. So we get 4. And now 4 plus, this is going to be 3. 3 times 4, 12. And we get 0. Remember, if we have a linear term, our third number is going to be our remainder. And in this case, our remainder is equal to 0. Okay? Which proves that, first of all, this theorem is correct. And second of all, that actually, oh well, and let me give you the answer, of course, yeah. So from this, we get that the answer is going to be of this division of x squared minus x minus 12 divided by x minus 4 is going to be equal to x, remember the first coefficient, plus 3. Exactly what we have in here, okay? So I hope this is giving you a good perspective about like factors and the polynomial remainder theorem, okay? It's pretty cool, and I think it just gives you a lot of intuition and like a good way of organizing your thoughts and procedures in math when you're playing with algebra, basically. I mean, this is just showing you all the connections that you can find in algebra. So I think this is pretty cool, and well, I hope you guys learned something today, and I hope to see you in the following video. See ya!